Thank you, Francesca, for the introduction. I am Francesco Facchinelli. I'm also part of the Jean Monnet Center of Excellence on Climate Justice, and I'm here to present this contribute, which was developed from me, Giuseppe Della Fera, Edoardo Crescini, the Professor Massimo De Marchi, but it is a collective work of our research group, Climate Change, Territories, and Diversities. I'm very, for me, it is very important to point this out. Well, I just changed the slide. Okay. A short introduction on some theoretical issues. Maybe you already know about the unburnable carbon concept, which was created in the 2015 from McGlade and Aikins, which with a study published on Nature highlighted how we can, if we want to stay in a world less than 2 Celsius degrees warmer than the pre-industrial levels, we should live in the ground more than one tenth. We can use, sorry, less than 1/10 of the current fossil reserves that are underground. Well, then some years after, the IPCC set a new target for the global warming, going down to 1.5 Celsius degrees, and thus leading to the actualization of how much CO2 we can emit if we want to stay below, to avoid the drastic impacts on social and environmental systems. Well, this led to an actualization. So now we know that regarding to current oil reserves, we should live underground 60% of oil, 60% of gas, and 90% of fossil carbon. In this frame, as you probably already know, there is the concept of climate justice. One thing that it is important for me to point out about this concept, which is pointed out also from Robinson and Shine in the study of 2018, is that climate justice can be achieved solely through the involvement of local communities, and also that local communities can play an active role in leading to policy change toward the achievement of climate justice. Another important concept for us is the one of the unlinkable carbon. This study shows that if we do not take count of, if we take count of the liquid emissions during oil extraction, we change the previous estimates, leading also to live underground. Those are percentages of how much of the gas reserves in percentage should be left underground if we take count of this leakage. So 127 means that more than the actual reserves of gas should be left underground. In this frame, we studied the gas flaring, or mecheros petroleros, as they are called in the Ecuadorian Amazon region, which consists in the combustion on site of gases, mainly methane, which happens during oil extraction. These in the world are flared about 150 billion cubic meters of gas each year, and it causes the emission of about 1% of global anthropogenic CO2 and 4% of black carbon. It has also a wide range of local impacts on local communities and ecosystems. I will not say them all now, just to be a bit short. Well, and now we have our geographical framework. As the previous presentation we are still in the Ecuadorian Amazon region. I will just point out that this is one of the most biodiverse parts of the whole Amazon rainforest. This is a study from 2010, which shows exactly this fact. As you already know, there are oil activities in this frame which overlap with biodiversity conservation area, and also areas to for the protection of indigenous people, and some of those indigenous people live currently in voluntary isolation. The Amazon rainforest has also an important role on the climate regulation in the whole world. The study shows that deforestation in the Amazon can, as well as other rainforests, can lead to changes in climate and agriculture all around the world. Okay, so it is not only a local issue. And well, with our Amazonia project, we worked with two organizations, the Unión of the Afectados para Texaco and the Fundación Alejandro Lavaca, which are located in the Ecuadorian Amazon region. And we decided to inspire to different approaches regarding how to make participation. One, as you have seen, it's extreme citizen science. Another is community-based participatory action research. And another one, it's for us geographer, it's very important. It is the participatory geographical information systems. Each of these can be linked to some part in which one or others of the our partner were involved in the in all the phases of our work, from the definition of the research goal to the dissemination of the results, to using the results of our work, as we will see better after, and leading to many different results which improved, of course, the work. Well, just a moment to speak about the technologies that we used. We used data from the National Oceanic and Atmospheric Administration regarding gas flaring satellite gas flaring activities monitored from satellite imagery. We elaborated also ourselves this data, creating a new dataset. And then for the participatory mapping part, we used the field, GeoODK, and ONA. For us, it was very important to work in an open source and free environment. Just an overlook of our data acquisition system. It was very simple. We had an ID, special data, a photo, and an information. Anyway, it was designed in order to provide proofs about what we were mapping, which were the gas flaring sites. Sorry. Thus, we developed our participatory mapping process. There are different phases of the work, from the design to the work on the field with local communities, to local organizations member, which then acquired the capacity to map autonomously the gas flaring sites. Well, the results regarding this part of the work were an amount of gas flaring sites which was really high, also in comparison to other datasets. We mapped the 305 gas flaring sites and 448 stacks. Of those, 76 were in the Yasuni Biosphere Reserve and 4 in the core area. This is the map regarding gas flaring sites, which was then produced. Well, then we compared our data with already existing datasets. This number show that we mapped like 200 more sites than the annual data set produced from the NOAA, then 179 more than what mapped from the our elaboration of the satellite data of the NOAA, and more importantly, 198 more than the Ecuadorian Ministry of Environment. This is the map that shows where are located all those sites, and the difference. We see that there are an entire cluster which were not included in one or another dataset. Well, the participatory mapping allowed us also to map some additional impacts. For instance, the gas venting activities, the presence of insects in the surroundings of gas flaring sites. We are in one of the most biodiverse places in the world, probably. I'd like every time to remember this. And another phenomenon regarding the rain of oil, we call it in this way. It is what happens is that sometimes some oil goes in the flow along with the gas and is expelled from the gas flaring sites. Going in this case, for instance, in the field of a farmer which was near the gas flaring site. Then we produced some materials for the dissemination. This is a story map. We made a report which then was used from the campaign Apaguen los Mecheros, Incendian la Vida, to develop a legal action to ask a moratorium regarding gas flaring activities. This happened in 26. This led to the ban of gas flaring activities declared in the 26th of January of 2021. And then we had a sentence which declared that all the gas flaring sites which were near populated centers had to get closed in a time frame of 18 months, and all the others before 2030. So it is a very wide difference, and for us and also for our local partner, it was not clear what it was, what it does mean near and populated center. Thus, we made some preliminary analysis.
2 minutes left.
Thank you. Preliminary analysis using different distances, different metrics of impacts to create some different scenarios, and choose seeing that with a distance of 2 kilometers, 0.25, we have the 88% of gas flaring sites which should be closed, for instance. And well, this is the map. As maybe you did not notice it before, but with a buffer of 5 kilometers, we have only one flare which should remain active, and it is actually in the buffer zone of the Yasuni Biosphere Reserve. So our results mostly show how there is like not a way to develop this kind of activities without having an impact on human settlements. This other map shows how, if we use, in this case, I use the wider metric, and there are multiple, many communities which are impacted from multiple gas flaring sites, from 1 to 3, and two, there is an issue regarding exposure from multiple sites. Now, which are the considerations which can be drawn from this work? Firstly, for sure, is that the involvement of local NGOs and local communities in the project from its starting part enriched the work in many different ways. For instance, leading us to increase our study area. Initially, we were thinking about working only in the Yasuni Biosphere Reserve, increasing the relevance of our work, as the presence of local organization and local communities is what allowed us to map sites not seen from the satellite.
30 seconds.
Thank you. And well, I will cut it short. So this the last main point that I would point out is that this work shows how scientists working with local communities can support them in their struggle to achieve climate justice. But local communities are not somebody which is like waiting to be empowered, or which somebody should give them the word. They can be a very active subject in our in the achievement of climate justice. There are some bibliographic references, and that's all. Thank you for your attention.